Pamela Hill. She's essentially going to talk about Kotlin. Brief intro is Pamela Hill is a second-generation coder and holds a BSc IT and BSc honors in computer science from the University of Pretoria. She has more than 15 years of experience writing desktop, web, and mobile apps, and she loves Kotlin and has recently joined Luno. So let's have a look at your Kotlin. Thanks, Pam.
Thank you. Good morning. How are you all doing? Good. All right. So yeah, I'm so excited to be talking to you about Kotlin today. I love Kotlin, and it's one of my favorite topics. I can't stop talking about it. So my name is Pamela Hill, as Visi introduced me, and I'm an Android engineer at Luno. Yesterday, I was the Kotlin principal at DVT, and today, I'm an Android engineer at Luno. So let's get started. So today we're going to be talking about a lot of sort of intermediate to advanced topics in Kotlin, but it's okay if you just know the basics of Kotlin. It's perfectly fine. It maybe will give you some inspiration on getting started in Kotlin. So we're going to be covering some coroutines. Coroutines is like a really hot topic in Kotlin right now. Also conventions, domain-specific languages, or DSLs, and we have quite a lot of time for a Q&A. So if you have a question, just kind of note it down, try and remember it, and then you can ask me afterwards, or during Q&A, and afterwards at the lunch, you're welcome to, while I'm munching on a samosa or a sandwich, you're welcome to come and ask me. I'll just... All right. So let's blast off on coroutines. So I was fortunate enough to actually attend Kotlin Conf this year in Amsterdam, and it was beginning of October, and during the keynote, Andrei Breslov, the lead language designer of Kotlin, actually said that he announced that coroutines had gone from experimental to stable, but also that this year would be the year of coroutines. So it's really big right now. You'll see a lot of articles going out, a lot of, especially for Android. So what's also nice is that during the conference, they had a whole workshop for asynchronous programming, but they also had a very nice, about 4 sessions just speaking about coroutines during a 2-day conference. So coroutines is big, guys. All right, let's take a step back. Let's think a little bit about where we come from. And we start with threads. So when you think about threads, you think, okay, it's definitely not cheap. So you have some memory that you have to allocate to it, you have to have some processes or a process, and you have to do some context switching. So it's definitely not a cheap technique to use. Then it's also not infinite, so it's limited by your underlying operating system, and we'll actually see this in the demo that I have a little bit later. It's also not available on all platforms. So for example, on the JavaScript platform, it's not available. I'm not an expert in JavaScript, but I think this is true. What I am an expert in is creating bugs. And with threads, you're kind of prone to creating bugs. You get a lot of race conditions, all kinds of nasty things, and it's extremely difficult to debug. All right, so next we have callbacks. So with nested callbacks, the more we nest callbacks, the closer we approach callback hell, right? So it becomes really difficult to understand and reason about. It's also a very different programming model. It's not quite imperative where we go step by step through a process of solving the problem, but it's kind of, all over the place. And the error handling is quite complicated. So very closely related to callbacks and is the concepts of futures and promises. So once again, the programming model is quite difficult to understand. So whenever you have and secondly, if you have a future or a promise kind of library, every time you have to learn a new API. So if it's a future-ish kind of library or a promise-ish kind of library or something new and exciting, you have to learn this new API every time. And like callbacks, the error handling is quite complicated. So in recent times, we've definitely improved, and we're looking at reactive extensions now. So Rx, RxJava, RxJS, and it works on the concept of observable streams. So it's data that is considered infinite and can be observed. So what's nice about it is that it's consistent across platforms, and it has a much better approach to error handling. I believe there's going to be a great Rx talk a little bit later, so definitely attend that one. But also keep in mind coroutines, coroutines, coroutines. All right. Okay, so finally we get to the topic of this section, coroutines. And coroutines works on the concept of a suspendable computation. So it's basically a computation that is kind of suspends at a point in time and then resumes at a later point in time. Now, I'm going to keep on saying like without blocking the thread a million times, but this is key about coroutines. It's without blocking the thread. So whenever the library designers actually introduce coroutines, they always say it's like a lightweight thread. And this is kind of true. It's a good analogy. And coroutines run on a shared pool of threads, and one thread can run many coroutines. Some of the advantages of using coroutines, my favorite is the way that you actually program. It's a very natural kind of style of programming. Your non-blocking code looks a lot like your blocking code. Second of all, it's very consistent across platforms. So, and this is because the compiler actually handles all this details in the background for you. And you don't really have to learn a new API because the standard lib, you can actually use the standard lib functions with it. You can use flat map and filter and map just as you normally would. So you may be a little intrigued, but you're like, is this really going to work? So let's have a look at a little demo, and we're going to start with your first coroutine. So what this little section of code does is it launches 100,000 coroutines, each waiting 10 seconds and then printing a dot. So that's an interesting challenge. It's a weird challenge, but it's an interesting challenge. But let's start by actually seeing we have a challenge between threads and coroutines. So we're going to start by launching 100,000 threads and see what happens. So this is just Kotlin code for launching 100,000 threads. And we almost immediately get an out-of-memory error, right? We can't create so many threads. The operating system is freaking out. So it pathetically kind of tries to print out a couple of dots, but it's really not up to the task. All right. All right, next up is our coroutines. Again, 100,000 coroutines. And there we go. So the reason for the 10 seconds is just so that we can actually, at the same time, have 100,000 running. If you make the duration too small, it will actually cause a problem because you actually won't be launching and running those coroutines at the same time. So as you could see, successfully printed 100,000 dots. You are welcome to come and count them. I will show you the video or send it to you, and you can count them, I guess. But we're Android developers, some of us. We have better things to do. All right, so to give an idea of how everything is related, I drew this diagram to kind of give the core concepts and how they are actually intertwined with each other. So everything is related to everything else. So at the top, we have our scope, our programming scope. And this is just your normal typey programming scope. Then you have a coroutine builder, which launches the coroutine, which runs a suspending function. Then we also have the coroutine context, which is basically a configuration object. And it specifies a dispatcher. Now, this dispatcher is important because it controls which threads you're actually running on. But don't worry, we'll see this again. We're just going to quickly go into the details of each one of these. So, some key concepts. Now, together with suspending functions and Coroutine Builders. Those two are the bread and butter of coroutines. So once you get started with building your own coroutines and so on, you're going to definitely be using those two concepts together. So a suspending function is basically a function that can be paused and then resumed at a later stage without blocking the thread. So how do I define a suspending function? All that I have to do is I have my function signature and I just add suspend. So just a little modifier to that function signature. And then just note that you can only call a suspending function from a coroutine or another suspending function. It kind of makes sense. It's a little asynchronous kind of thing happening, so it makes sense. And then under the hood, the compiler does all the hard work for you. It converts the suspending function into a function that actually has a continuation. So a lot of stuff is happening under the hood for you, and it actually makes your code very nice and clean. All right, the coroutine context is just a configuration object. Now, the first key value, it's a key value map. So the first kind of entry set in that map is your job. Now, a job is really there to cancel the operation. If you have very long or costly kind of operation, you definitely want to be able to cancel something. And you can also use it to kind of check the state of the operation. Is it active? Is it cancelled? What's happening? You get the concept of a continuation interceptor, which is basically a dispatcher. I'm not going to say too much about that. It's the dispatcher that we're going to look on the next slide about. If you want to debug, it's always important to debug, right? So if you want to debug, you're going to have a coroutine name that you can just assign anything to. And you have an exception handler. So all the exception stuff is handled by this exception handler in that context. So as I said before, a dispatcher is really something that will determine which threads we're running on. Is it the execution of the suspending function, or is it the continuation? What strategy are we going to use? So you have a couple of options. For instance, we have dispatcher.default, which is for very computation-intensive tasks. So the equivalent in RxJava would be something like schedulers.computation, I think. Then for dispatchers.io, IO-intensive stuff, schedulers.io would be your kind of equivalent. The dispatchers.unconfined is an interesting one because it actually, you start on the running thread, but you resume on something that's dictated by the suspending function. And then finally we have the main, Android main, it's running on the main thread. So, as I said before, suspending functions and coroutine builders are the bread and butter of coroutines. So they simply start the coroutine for you. And it basically gets the context, the configuration object from the scope that you've actually invoked it in. And some examples are things like launch and run blocking and async. So we definitely want to look at this little diagram again, right? It's quite overwhelming to go into details like this. So we have our programming scope. We have our coroutine builder, which launches the coroutine, which runs the suspending function. We have a coroutine context, which is inherited from the scope and specifies a couple of things, like the dispatcher, which controls which threads the coroutine runs on. Make sense? Good. All right, so my example for coroutine builders is based on space. Since I just started at Luno, and since that's our theme, it's a natural choice, and as is one of our coroutine builders' names, launch. So my first two examples are based on launching the space shuttle and flying it to the International Space Station and docking there. And it's basically just using a coroutine. So how would I go about using launch? Now, launch is a fire and forget kind of coroutine. And it returns a job, which you can use to cancel your operation with. Okay. So my example basically works with 3 suspending functions: launch, fly, and dock. Those are kind of long-running operations. So this is my coroutine. So just to kind of, I'm old school, I print things out. It's not always the best strategy, but it gives you an idea of what runs where, right? And it's also really impractical to do a debug session right now. Okay, so we're going to launch the coroutine and print some stuff, do some stuff, print some stuff, and print some stuff. So if we were to look at what's actually happening here, we'd basically see that once we start the program, we'd immediately see what were we doing again, which is way at the bottom after the coroutine. And then we'd get 10, 9, 8, ignition. And then later on, a couple of days later on, we'd actually get docked. All right, so if I were to now substitute launch with run blocking, which actually waits until the coroutine is done, we would actually get a different result. Now, just note that for run blocking, you can actually use it for unit testing. There are some libraries, I think Mach-K actually has some constructs for unit testing coroutines. You can check it out. I'm not really sure about that one. But same example, instead of launch, run blocking. So here we would get something like 10, 9, 8, ignition. And then a later stage docked. And then that was amazing. All right. So with async, which is another coroutine builder, we actually return a value. So the use case is different, and then the example is different. So it returns a deferred, and a deferred is really something that extends from job, so you can use it to cancel. But it also has a wait function. Now the wait function is really to wait until we have a result and then return it. It's also a suspending function, so you always have to call from a coroutine or a suspending function. All right, let's have a look at our example. So while we're now flying to the space station, we actually want to check on the health of this mission. And we want to check whether we're still on course with the space shuttle, and we want to check, is the crew still healthy? So those are kind of long-running operations. We kind of want to put them in suspending functions, right? And then we want to take the, sort of make a report out of those two variables, or whatever you want to call them, and you want to create a report, and you want to send it to mission control. So that's just going to be a simple function, not a suspending function. And then you would create a kind of parent coroutine called launch, which is just, as again, fire and forget. And then we have two async ones that will run the flight path checking and the crew health checking in parallel, so at the same time. And then it will report to mission control. Basically, we'll wait for both of them to run. So it will take the maximum of the longest. Because it's running in parallel, it won't be taking the sum of the two. It will take the maximum of the longest. So that will probably be something like checking the crew, because people. All right, so, and then it would report to mission control. So if you're interested in coroutines, definitely have a look at a very good presentation by Venkat Subramaniam, who is a fantastic live coder. He's really, really great. And he never gets phased. He's just very knowledgeable, and he actually did 2 presentations at Kotlin Conf. It's called Exploring Coroutines in Kotlin. And there's also an article by somebody whose name I didn't practice, excuse me, called Async Operations with Kotlin Coroutines. Now, part 1 and part 2 is very based on what we're talking about today. Part 3 is quite advanced and works with channels and actors and so on. You're also welcome to follow Roman Elizarov on Twitter and Medium. He is the coroutines guy. He actually is the lead library designer at JetBrains for coroutines. And if you're an Android dev, have a look at Android Suspenders by Chris Baines. He also spoke at Kotlin Conf. And there's also a Google Code Lab that we actually did during the workshop at Kotlin Conf called Using Kotlin Coroutines in Your Android App. And it's a really good way to solidify your knowledge. All right, so we've had a look at coroutines. And next up is conventions. But first, a sip of water. Do you want to stretch? Are you still okay? Are you still alive? All right. Just out of interest, like, how many Kotlin coders do we have? That makes me very happy. Hopefully we can convince the rest to join us. All right. So with conventions, I want us to take a quick step back and think about, have like a little retro Java moment. So remember that when we implement the iterable interface on our classes, that we can actually iterate over elements in our objects with the for loop construct. It's a nice feature. And when we implement the comparable interface, we can actually, in our class, we can actually sort a collection of our objects using the collections framework. So what can we kind of deduce from this? Well, Java relies on a class having a very specific type in order to use it with a language construct, like the for loop, or a framework, like the collections framework. What if you can't change the class? Enter Kotlin conventions. And Kotlin uses functions that have very specific names with certain language features. And these features actually, these functions are basically said to follow a convention. So what we can do, what's great about Kotlin, is that we can use extension functions, right? So we can take our existing classes and create an extension function that follows a convention so that we can use it with our Kotlin language features. Pretty great. Okay, what conventions are there? Well, there's arithmetic, some comparison ones, some collection and range-related ones, and then destructuring declarations. So those are the ones that we're going to be covering in this session. There's also delegates, but because we only have a limited amount of time, we're not going to go into those. So once again, we have our little example of flying to the space shuttle to the space station. So if I wanted to model this a little bit and kind of measure the distance between the space station and the space shuttle, I could model it like this. Now, I only use TD. I know there's 3 dimensions or 4 dimensions or how many dimensions there are, but I just kind of tried to make things simple and stayed with X and Y. Okay, so we have a data class. It makes things nice and simple. The compiler generates a lot of stuff for us. And then we have our space station position and our space shuttle position. Now, if I wanted to measure the distance, I would just say space station position minus space shuttle position. Easy as that, right? Where's the implementation? Here it is. All right. So we have a specific function called minus, and together with that, we use the operator modifier. Okay, so it's following the minus convention, the minus arithmetic convention. Now, it doesn't matter what you actually pass in as a parameter or as a return type. You can actually define for some of the operators, it's very flexible in terms of what you can actually use with the convention. Some of them are not. But in this case, we're passing in a point and we're returning the distance. So we're doing some maths there. It's very exciting. Let's go on. All right. So for arithmetic operators, we have a certain syntax for binary operators. And then for unary operators, we obviously don't have an extra parameter that gets actually passed in. So Kotlin has a very limited set of operators that you can overload. And I think the reason for this, and the language designers have actually spoken about this, is you get people that get kind of funky with their operators. So you don't want to actually have somebody that defines a smiley face operator and then nobody knows what it means like 10 years later. So you definitely don't, you want to restrict the amount of operators that there are. And notice again, the parameters and the return types don't actually have to be the same type. With comparison operators, we have the any class. Now, the any class is the superclass. It's like a Java object class of Kotlin. So the any class actually has an equals method, and it, together with the not equals and the equals operator, we actually they kind of work together. So if I wanted to determine whether from the origin, which is Earth, the space shuttle position is less than the space station position, in other words, which one is the furthest away, I could just use this notation and this convention, the compared to convention. Now, this one is fixed in terms of parameters and return types. It's like with Java, we have our negative numbers, our equals to 0, and our positive numbers, and they would basically say less than, great, or equal, and then greater on. So that's kind of how that function implementation would work. If you're a little bit lazy, or if you want to kind of shortcut through things, you can use the compare values function to kind of implement this function. It's a standard lib function that you can use. All right, for collections and ranges, we have the index operator to kind of very easily get and set values in a very concise, nice syntax. So if I wanted to kind of read the space shuttle position, I want to check where it is, or I want to set it to, I want to update it now, I can simply use this notation and the get and set conventions. I'm going to go through these quite quickly because the important thing is that a convention follows a naming and an operator modifier thing. So if you want to use it, I think it's best to kind of just keep that in mind. All right, so the in operator can be used to determine whether you actually have a value in a collection or a range. So if I have a flight path determined, and the flight path actually says, okay, are we still on course to getting to the space station? I could use this operator to check whether the space shuttle position is in the flight path. Now, what's nice about this is that we're actually kind of reading very fluent. It's almost like natural languages, right? It's reading very nicely. And we'd use the contains convention with this. The in operator can also be used to iterate over things in a for loop. So we can actually, if we have checkpoints in that flight path, we could actually iterate over those using the iterator convention. My favorite convention is the destructuring declaration. So here we can very succinctly assign the space shuttle position x and y coordinates to some variables. Pretty cool. And for this, we'd use the component in convention, starting with 1, weirdly enough, starting with 1, 2, and all the way to n. Now, for data classes, the compiler will automatically generate this for you. But when you think about this, think about it carefully, whether you want to use your destructuring declarations, especially if you have a very big data class. If you have a person with 10 million kind of attributes or fields or properties, you actually don't want to do that. But for something like a color, like RGBA, we know what the different values are, and we also know the ordering of those values. So that's really great. That's a really great use case for that. All right, so if you want to do some further research, have a look at Kotlin in Action. Now, Kotlin in Action is the classical book on Kotlin, but some books are also fantastic. So definitely have a look at that book. Rebecca actually got me into Kotlin with this book. And I also wrote an article recently called Improving Readability Using Operator Conventions in Kotlin. It was just published in Pro Android Dev this week, so have a look at that one if you're interested. All right, so we've had a look at coroutines and conventions, and let's have a look at domain-specific languages, or DSLs. So what's a DSL? A DSL, let's compare it with a general programming language. So if a general programming language actually solves any problem that a programming language can solve, DSLs are very specific to a specific domain. That kind of makes sense, right? But a GPL is also very imperative. It describes how we're solving the problem. Whereas with a domain-specific language, it's declarative. I want to describe what the result should be. All right, so our astronauts have gotten bored on the flight to the space station, and they started playing Space Invaders, and they have a leaderboard. So a good example of a DSL is SQL, right? Or regex. That's some good external DSLs. We'll compare internal DSLs a little bit later. So let's have a retro SQL moment, because it's a DSL. So if I want to have a look at the leaderboard, and I wanted to select, so I have two tables, right? I have the player table with the player ID, name, and country, and I have a stats table that has the player ID, and the score, and the rank, and things like that, and the month. How would I kind of get that leaderboard out there? Well, I would select the fields from the tables based on the month and kind of join things and then order by rank. So that's how I'd go about things. So what's nice about this little code snippet? Well, it's really concise. It sort of goes in and goes out and describes the solution. It's also very fluent language. So my best friend is called Taryn. She's an L technician, and I'm pretty sure she could read what that said. So, and read and understand. And it's also very maintainable. So readability and maintainability go together. So if you can read what the previous person did, you can definitely understand and kind of adapt things and fix bugs. But what's the disadvantages of DSLs? Well, you get something like this. When you want to take SQL into a Java program, you have to do some serious string concatenation and some serious parsing, right? And it's ugly. So what you can do is you can use an internal DSL. Now, an internal DSL is written in a GPL, a general purpose language, and it is restricted in the way that it actually expresses of itself, but you never have to do string concatenation or parsing. So with the exposed framework, for instance, which is available to anyone, you can express the same query really fluently. Now, Venkat Sabriam actually has this concept of fluency. Now, that actually means it reads like a natural language, and that's key to actually understanding your code. So in this case, we're joining the two tables, getting some fields, joining based on an ID, and getting the month-specific stuff, and then ordering by rank. So if you're an Android dev, you can actually define Android UIs using a DSL. In this case, the Anchor framework provides that DSL for you. All right, so there's a lot of language features. Kotlin has a lot of things going for it in terms of DSLs and creating very fluent DSLs. For instance, the semicolon issue. I know a lot of people actually don't like throwing away the semicolon. They're kind of hesitant to throw it away. Their pinky is used to. All right, but it removes, by having it optional, it removes syntactic noise. And that's sort of key to actually having very fluent DSL. By dropping if we have an infix function and we drop the dot and the parentheses, we can also kind of have a very fluent way of writing function code. For instance, if we had a string should start with space, that reads a lot better than assert true string dot starts with space. It's going to read a lot better. With extension functions, we can actually make existing code really fluent. And as you know, if you have a function with a last lambda argument, we can also kind of remove the parentheses. So that also removes syntactic noise. Now let's have a look at lambdas with receivers and invoke conventions. Now, it's a pretty advanced topic, or a little intermediate topic. So don't worry if you haven't seen those before. So you've probably used it though. So a lambda with a receiver, a good example is the apply function. Now, apply function is typically used when you want to initialize your object. So in this case, I have a Space Invaders player, and I want to kind of assign different things to it. So the ID and the name and the country. Now, see how fluent this actually is. You know, I'm not using this dot or it dot or anything like that. There's nothing getting in the way. And what I noticed as well is no semicolon. All right, so this is kind of what it looks like. So we have a block as a parameter, but it looks like an extension function. And this is for, you know, this is part of the syntax. So what t, the generic parameter t, actually becomes, in our example, is it's a player. And the player actually becomes the receiver of the Lambda. So we don't actually have to qualify it with this or it or anything. We can just use it as is. And so it's also, Lambdas with receivers is probably going to be used the most used language feature for creating DSLs. Each Lambda has its own sort of name resolution rules, so we can actually create very type-safe DSLs. The Invoke convention is kind of a strange one because we're so used to actually, you know, when we invoke something, a function on something, it's typically object.action parameters, right? So here we actually use an action object and an action kind of named variable. So in my example, we have a move action, and we can move to the left, 5 positions to the left, invoking it on the object. That's kind of strange. All right, so we're moving 5 positions to the left or to a target point. Okay, and then we basically use the invoke convention again. We can overload the invoke convention, and we can specify any parameters we want. But the key here is that objects are called as functions. Now, you actually have seen this if you're Android dev and you've used Gradle before. You know, in dependencies, when you say compile with the parentheses, that's it. That's the invoke convention. So let's kind of wrap things up and kind of put everything together. Now, I've underlined a certain section of our DSL from before, and let's kind of try and identify what happens where. So the select function actually is an extension function, and the parentheses that actually, the parameters that actually get passed in is a Lambda with receiver. The equals method is an infix function and also an extension function. So you kind of see that if you choose your language features very carefully, you can create a really nice and fluent DSL that you can write very nice code in. It will be concise and readable and like super maintainable. All right, so if you wanted to do some further research on DSLs, have a look at Kotlin in Action, Chapter 11, DSL Construction. And Uncle Venkat has also given a fantastic and other course on creating internal DSLs in Kotlin. It's really good. I enjoyed it so much. And yeah, so we've covered coroutines, conventions, and DSLs. And now it's time for a quick Q&A. Any questions? Sure.
Just wanted to find out that in the beginning, the difference with coroutine and async, is it that with async, you could block the thread, but with coroutine, you could fire it off and it could come days later like a notification. So that's probably where you use coroutine.
So it's a different kind of, what I listed was different kinds of asynchronous programming techniques. So for instance, callbacks and features and promises, they're all kinds of different asynchronous programming techniques. But coroutines has the distinction of not blocking the thread. So it's still, it still has the normal programming model for like a very step-by-step programming model. But it also has this, this benefit of not blocking the thread. Does that kind of answer your question? Right.
Understand.
Okay. Any other questions?
Yes. It's a general Kotlin question. Does Kotlin have type
So what's nice about Kotlin, so look, in Kotlin we definitely have the concept of type erasure because we're based on Java, right? So what they do have is there's a certain modifier, I think it's called reified, that you can use to not lose your parameter types at runtime.
Sorry, what did you say?
Reified or reified. All right. Any other questions? Sure.
Yeah, you mentioned something about a framework used to test the coroutines.
Mock-K, I think it was. Yeah.
And are there any others?
Not that I know of. I haven't actually unit tested coroutines before, so I'm not really sure if there's anything. But there's a lot of, as we actually get more and more community involvement in coroutines, I'm sure there's going to be lots and lots of libraries and frameworks that are going to help us.
Sorry, in your launch, so you had your launch there and then you did that. Now say the application ended off that. Will the application wait for the launch, everything in the launch to complete, or will it actually just end?
No, it won't. So it's definitely, that's why we normally use a run blocking kind of thing. So the application, normally what you do is you'd actually have a little delay like a thread.sleep kind of thing happening.
With the operator overloading, are you able to overload the array operators to accept a string for indexing using a hash map internally?
Can you just repeat your question?
So normally when you override the array operators, you have it as an integer to get the index. So say internally in your class you have a hash map that's string indexed. Could your array operator be defined to accept a string?
All right, I'm not really sure right now, but I'll definitely take your contact details and I'll get back to you. I'm kind of freaked out right now. Okay, so we're going to have a little competition. We have Kotlin Apprentice and Kotlin, Android Apprentice from our sponsors, our lovely sponsors. And I wanted to know just some of the benefits of coroutines, just one, if anyone. Sure.
So it doesn't block. Okay. That's
Mm-hmm.
okay. For instance, with your async, you would have with your asynchronous programming. If there's something happens with your async on the main thread, it blocks that thread. So the nice thing about coroutines as well is it doesn't block it at all. So while that heavy task is busy processing, I'm saying I'll get these step aside, let myself let everything that I need get processed, and when I'm done and I'm ready, I'll come back and just continue. So everybody else that needs the thread now just continue. So I think that's
All right, cool. Come have a look. Pick one. Choose the Kotlin one. Sure. Okay, so we kind of had that answer already. Is there another answer? Okay, it's just the one. Okay, sure. All right. Thank you very much, everyone. I've really enjoyed talking to you, and keep in touch. Thank you.